So before enter into the today's class, let's see what we studied in the previous class. Let us recap that. So we started with the basics of Verilog HDL language, then how the structure will be in the Verilog HDL language. Here, this is the structure we seen in the previous class, how the Verilog program has been written. But the Verilog language, that is Verilog HDL, has three different types of modeling. The three types of modelings are already not only three, so many modeling, different types of modeling: data flow modeling, structural or gate level model, behavioral model, mixed type, then mixed model. So we started with the data flow model. The data flow model specifies the Boolean expression in the sense, so you can write the program for the given Boolean expression. That is what will be in the data flow model. So here, this is the complete the syntax of Verilog HDL. We can see here the module. The module is a keyword. The module followed by the module name. The module name is a identifier. So the identifier in the sense what? It is a username. So you can give any name here. So module name in the sense of there is some set of rules you need to follow to write the module name. What are the rules we said earlier? The module name should not start with number. The module name should not start with special character. The module name should not end with number. The module name should not have the spaces. The module name should not have between the two names you should not have the hyphen. This is the underscore actually. You should not have those also. So, but you can mix up all those things in the module name with a single identifier. That also you can do. Followed by, you have to give you a bracket like you have to list out which are the inputs, which are not the outputs. That is why here I specified list of inputs, list of output. Even it may come list of output, list of input. So don't interchange, like say example, A, B is input, Y is output means don't write as like A, comma, Y, comma, B. That is, it's not like meaningless actually. So A, B and Y. So now next what you have to do, the system doesn't know, so which is the input and which is the output, because we given only the variable in the module, that is list of input and outputs. So to know the system which is the input and output, we need to specify separately the input is, which are the variable is specified, that I'll give. So input followed by list of inputs, the output followed by list of outputs. So here so many declarations will come. So this and all we'll study later one by one, because later we use in the program one by one declaration we use. At that time we'll come over this. Next, after that, what you know, this is the things we've seen, how we are going to comment the Verilog actually. Because as you studied in the C program, if you want to comment a single line, so we'll use a double slash, that is backslash we'll use. But if you want to comment multiple lines as like one paragraph, then you have to use like this. As you know, what is the meaning of comment? If you comment any one line while the system executes the program, while the compiler actually, so that line will be skipped. That is what will happen when you do the comment. The same thing you might have done in your C language or C++. The same thing even here also. Next, here we are using the data flow model. So data flow model in the sense, so you must to use the statement called as assign. Keep it in your mind, don't forget. Assign, ASSIGN. This is the keyword actually, followed by the target signal. The target signal is nothing but your output signal equal to the input signal. Like this will be the computation, like it will be evaluated. The input signal will be evaluated. The value will be assigned to the target signal. That is the meaning of this assign actually. So here the statement, that is what, which is statement means I can say this whole thing only I can say as statements. Statement 1, statement 2, so n number of statements will come. We seen the examples also we seen. Once it gets over, finally you have to end with end module. There is no space between end and module. It is a single word. Then one more very important thing, there is no semicolon after the end module. You can see that module, there is a semicolon over there, but end module, there is no semicolon over there. But each and every line, there is a semicolon. The semicolon indicates that line is break. So if you want to break the line, you must use a semicolon. Okay, so now what we seen after that, we took a simple example. We seen about the basic gates. The one experiment we seen here. So each and every statement we return with the assign. So next what we did, instead of using multiple assign statement, what we did, we replaced this by one single assign statement. Instead of giving semicolon for each and every line, we used a comma. Finally, we used a semicolon. So we closed with end model. This will work. So either this or this we can write. Now today what we'll do, we'll go to the next level. So the next level, what is the simple, one more thing I will take, I will write the program for, so write the Verilog code for half adder. So whatever the program I am writing here, so better always, I insisting you to write in your notebook. Keep the notebook with you, because without practice you can't do anything. Now one more thing, whatever I am writing here in my notes, it won't be there, because this is just before entering the first module, I am giving the prerequisite for you how it will be everything. So that is the reason I am writing instantly. I am writing the programs for you. So keep one notebook with you always. Better don't listen only this, you won't get anything, because meanwhile you should also work. I'll give some work, I'll give little bit some minutes also. You have to write the program to try, then you will get idea. Okay, so now what we'll do, let us write the Verilog code for half adder. Okay, as you know now, I no need to worry about the diagram of half adder. Why? Because we are writing the program in data flow model. If you are writing a data flow model, in the sense what you need to, we should know only the Boolean expression. So let me go for the Boolean expression. Like first is for half adder means sum is equal to A XOR B. Actually, I'm not using the symbol of XOR symbol here. Just I'm writing here A XOR B like that. Or let me use, okay, so A XOR symbol we can use, but I don't have that. So what I will do, better I will use that only. A XOR B. Next is carry. Carry is equal to A B. Okay. Yes. So this is the expression actually. Sum is A XOR B. Carry is A dot B. This is the. So now let us start with the program. Okay. First what you'll do, you have to start with module. Okay. Module followed by module name. You see here. Yes. Is there any confusion?
Serial number.
Please mute your microphone. I don't want to hear any more voices from your side.
Low life people.
Yes. So now let me write the program. So let's start. Module. Module is a keyword followed by what I should do? Half adder. See here, I will write as half underscore adder. I should not write half space adder. Or you can write like this also. HA. So the person half adder. So you can give anything else. So just what I'm doing, I will write as like this. Half adder followed by inputs. Which is the input here? A, B is the input. Which is the output here? Sum, carry is the output. Then put the semicolon. This is the first line. Second line, what I need to do? You have to write the input and output separately. You have to write. So for that, first input A comma B semicolon. Next output sum comma carry semicolon. So now this portion is over. Next what you will do, we are going to write the data flow model. So further what I will do, I will go for assign space. So each and every output you have to specify here. First sum is equal to what? A XOR B. Next assign carry is equal to A and B. This is actually A and B. Any more? So then you have to close with the end module. This is the program for half adder in using data flow modeling. Same the way, let me go for write the Verilog code for full adder using data flow model. Using data flow model. Okay. Now, what is the expression for this? As you know, sum is equal to Okay, sum is equal to A XOR P XOR C in. This is the sum expression. For carry expression is A B plus B C in plus C in dot A. This is the expression for carry. See, for sum is A XOR B XOR C in. For carry is AB plus BC plus CA. This is the carry expression normally for full adder. Let me write the program now. So how we can write the program now? So module full adder. Okay, full adder. Inputs are how many inputs? A, B, C, N. These are the inputs. Outputs are sum, carry. Then semicolon. Next input. Which is input here? A, comma, B, comma, C, N. Then output is outputs are sum, comma, carry. Then semicolon. Next, what I should do? Next, let me write the statement. Assign sum is equal to, what I should do? A XOR B XOR C in. Then same the way, assign carry is equal to A and, so ampersand symbol we have to use, right? So A and B, it's use the parenthesis better. A B. Then OR gate. OR gate is pipe symbol you have to use. Then A B B C in. C in. Then again pipe symbol, that is R C in and A. A B B C C A. Then semicolon. Then finally give us end module. This is for full adder. Now next what I will do, let me go for the next program. Like this is the very simple how to start. Now what I will do, let me take one of the simple another example. So for that, let me draw one symbol diagram. This is you consider as A, this you consider as B, this you consider as C, this you consider as something called as Y. Okay, now let me write the program for this. How we can write the program for this? So first let me start with the module, followed by what is this module? Like you can take anything else here, this whole thing. I will take it as something called as example. Example-1. Example. This is example will take. What is it here? A comma B comma C comma Y. Okay, fine. From this diagram. Okay. Next, you see, we'll take input. Which is input now? Input is A, B, and C. Then output is Y. Okay, fine. Now you tell me here. Like let us write now. Assign. Okay. First, how to write? If I'm writing Y is equal to, now you think, if I take this Y is equal to what? I know this C, but what about this? There is a question mark over there. Yes, what about this now? So we doesn't know, it's like what happened? This gate, the AND gate is driving this OR gate actually. The output of AND gate, correct? So this is what I can say. The output of AND gate is going to the input as for OR gate actually. So what is this? This is called as, we can consider as this one. This one we can call as net, or sometimes we may call it as wire. Normal wire. You think about your electronics, normal electronic in your breadboard. from one component to the another component, what you will do, you will use a one wire. You will connect from one place to the another place. That wire will carry some signal, correct? So wire will carry some signal in the sense, if there is any change in A and B, immediately the wire signal also will get changed. The immediate effect will be there. Correct. If this also get changes, immediately the Y also will get changes. That's we know. So now I can say this is nothing but a wire. So that is what I'm going to introduce now. The new concept here, it is nothing but a wire declaration. This is what I said. So first thing is we wish to study the syntax of this. The syntax, how it will be in the sense, wire is a keyword, then wire name. Wire name is an identifier, then semicolon. This is the syntax actually. Wire name. So this is, let me take as, yes, this is the syntax. Wire is a keyword. So now what I should do here, this is wire, you should name it something. So what is the name I can keep now? Let me take, what is the name we will take? That is left to us actually. Let me take this wire called as, I will take this wire, we'll take it as something called as X. Now what I will do now, let me introduce the concept called as wire actually. Wire, then followed by, what is the wire name here? Wire name is X. Wire name is X. See, I added. So now here what I will do, first I will write as X here. What is X now? X is nothing but now simple, I can say A and B. Next what I will do, assign Y is equal to, what is that this? Now you see, assign Y is equal to X or C. So X or C, then semicolon. Then finally you can close this, end the module. This is nothing but a wire declaration. The wire is nothing but, otherwise you can call it as net declaration. What is the wire here? The wire which will transfer the information plus one gate to the another gate. There is any intermediate signal between one gate to another gate, or I can say from one block to another block, that will be called as wire. So you need to separately you can do. But you may think without wire also you can write this program. How you can write without wire? Let me show how to write that. Without wire also. Say example, see this portion completely. Now I will replace the wire now. Without replacing the wire, how can I write in this? Simple, it's very simple. If I'm not using the wire, then my statement will become as like this. In a single line, I'll write assign Y is equal to, what is this Y now? Y is equal to A and B, because this has to be evaluated. This result R with C actually, correct? So R with C, then semicolon. Yes, this is what you can write in a single statement. You may think that then why I went for like this instead of writing in a single way. So when it will be useful in the sense, see example, if my Boolean expression is very large, but the number of input variables are more. See, consider if your number of inputs are around 32 or 64 variables. If your Boolean expression is very large enough, then what will happen? If I write in a single line, there will be some problem. The parenthesis problem will be there. While executing, it may throw some errors. So you couldn't be able to identify where exactly the error is. Instead of that, what you can do, you can break the Boolean expression. If you want to break the Boolean expression, this is what you get. Just you can add a wire, then you can split up your Boolean expression, then you can write the program. It will be very, very easy to troubleshoot. That is the reason we are using the wire. The wire will not store any information here. You have to keep it in your mind. The wire will not store any information. So just it will transfer from here to here. If there is any changes in the input signal A, B, immediately the wire also will get changed immediately without any delay. It will change. That is what I can say why. So this is nothing but a simple example with the wire declaration actually. Yes. So now what you can do, same full adder, you need to write with wire actually. So let me take a full adder diagram. See, I'll show. Yes, see, this is the diagram now we are taking example. I hope this diagram is visible for everyone. Okay. Now let us write, before writing the program for this, what you'll do, let us identify the signals. Is there any signals over here? First signal, you see, what is the meaning of signal? From 1 to this. So before that, I need to show what kind of this diagram actually. This is nothing but what? Full adder using 2 half adder actually. See, there is a 1 half adder here. Where is that? 1 half adder is here. This is the 1 half adder. This will be your second half adder. Okay, this is HA1. I can say half adder 1. This is your HA2. Then 1 OR gate. Okay, fine. Now let us see. Okay. First, what is the signal here? First signal is see this place, correct? I hope you can understand. This is the first signal, correct? No? Okay. Where is the second signal actually? Second signal is here. You can see from here to here is going. 2 signals. Where is any more signals? Actually, here 1 signal is there. Correct? That is the 1 signal. Any other signals? See, this is not the signal. Why? Because from here is going to input. The I is input actually. Is anything else here? So now the complete module, which is our complete module, listen here. So let me take the complete module is this. See. This is a whole module actually. A, B, C is the input, S and C. Now you can see where is the 1, 2, 3. So what I will do, I will name it as something called as I will name it as S1. This I will name it as S2. This I will name it as S3. Now let us write the program. So now here we will write the program here. First, start with the module. So now let us start to write this module followed by full adder. Module followed by full adder. Then inputs are A, B, C in, that is Ci here. So same thing I'm writing. Then S comma C naught. C out actually. C naught is C out. From this figure only we're writing actually. Next, input, which has input A comma B comma Ci. That is input C in. Next, outputs are S comma C naught. Next, now here wire will come. See, wire. S1 comma S2 comma S3. Now we will write assign. First we will finish S1. S1 is equal to what? From this A XOR B. From this figure only I am writing. See this A XOR B. Next assign. What I will do, instead of writing I put each and every assign, I will put a comma actually. Just it will be easy for you. Next S1 is over. Next let us go for S2 because we will complete all the wires first. It will be easy for us to write actually. S2, what is S2 actually? Ci. Next one more is S1. So S1 and with Ci. Right? Next, what is next is S3. S3 is equal to, what is S3? S3 is equal to 1 is A, one more is B. So A and B. Then this is, we completed with the wires actually. We'll put a semicolon, we'll start once again with the assign statement here, better. Assign. Now you write sum actually. Assign sum is equal to, what is the sum actually? S1 XR X1, right? S1 XR with Ci. Next, assign carry, that is C0, right? C0 is equal to, what is C0 actually? C0 is S2 S3. S2 or S3. Then end the module. Yes. This is the program for full adder using 2 op adder, using data flow, using the wire declaration. You can see now. I hope you might have understood this. Is there any doubt in this?